Hello everyone, welcome to lesson 5-2, which is chapter 5, lesson 3, angles of triangles. We will continue to apply algebraic concepts to geometry, and we are going to look at the following words: triangle, interior angle, exterior angle, remote interior angles. You already know 3 out of these 4. I can comfortably say, I think. Example 1. STEM, science, tech, engineering, math, right? Caroline and Emily are building a bridge out of toothpicks for a science competition. Emily thinks the sides should be constructed using triangles. Use the activity to find the sum of the measures of the angles in a triangle. So the sum, the adding all the angles and finding what they equate to. So let's see here. Lines M and N are parallel. That's true. Here's line M and here's line N. Lines P and R are transversals that intersect at point A. Line P, line R are transversal. They cross M and N and they meet at this point. They cross at point A. So what is true about the measures of angle 1 and angle 2? Explain. Well, we see that they are inside the parallel lines, right? And here's angle 1 and here's angle 2. You can see that they go across one another, so we can say they're alternate, and because they're inside, they are interior, so we can say they're alternate interior angles, right? Simply put, we say they are equal, because they are alternate interior angles. So angle 2 and angle 1 are equal. So, and then we can find over here, for example, that these are vertical angles and these are vertical angles, and we know that vertical angles are equal, right? And then we also know that adjacent angles are complementary and they make they add up to be 180. We only know angle 1, we don't know angle 5, or this angle here that's not labeled. But let's continue. What is true about the measures of angle 3 and angle 4? Angle 3 and angle 4. Same thing, right guys? They're both interior because they're between the parallel lines, and you can see that they're alternate, right? So what can we say? We say the exact same thing. We say that they are equal because they are alternate interior angles. All right, let's keep moving. Question 3. What kind of angle is formed by angle 1, angle 5, and angle 3? Let's see that. Angle 1, angle 5, and angle 3. What kind? Well, this would be a straight angle, right? And we already know that this angle equals this angle, right? Or, well, we can say that we have over here, we don't know if this one equals this one, but we know it equals this one, right? So we already know what these angles are, and we can solve for 5 because we know that the sum of all 3 angles has to equal 180, as it creates a straight angle. They create a straight angle. Angle 1 plus angle 2 plus angle 3. Oh, I'm sorry, I numbered those wrong. It's supposed to be angle 1 plus angle 5 plus angle 3, not 2. Angle 1 plus angle 5 plus angle 3 equals 180. Question 4. Use the information from exercise 1, 2, and 3 to draw a conclusion about the sum of the measures of the angles of triangle ABC. Explain your reasoning. So here we have triangle ABC. Triangle ABC, right? We know that we can solve here, and we know that this equals 180. So we'll understand what 5 is, right? Just by simply knowing what 1 and 3 are, and we know that the sum of all 3 have to equal 180, we can solve for 5, right? By substitution. We know what 4 is, and we know what 2 is, because 1 equals 2, 1 equals 2, and 3 equals 4. So we can solve the sum of all 3 angles, right? And the sum of all 3 angles should equal 180. That's what the sum of all angles in a triangle equal. So what can we say? I would say the sum of the measures of the angles in triangle, you like my little triangle, I can finish it with a little line underneath there. Triangle ABC is 180. So we know that the sum of all three angles is 180, and we've already solved for angle 2 and angle 4, so I understand that through substitution, right, I have angle 2 plus angle 4 plus x equals 180, right? And it would look something like this. Angle 2 plus angle 4 plus angle x, which is angle 5, equals 180. So we just solve for x once we know what these are. And we already solved those by using alternate interior angles. For our first key concept, we are going to learn about the sum of the angles in a triangle. So angle sum of triangle. In words, the sum of the measures of the interior angles of a triangle is 180. X plus y plus z equals 180. You see it here in symbols. X plus y plus z equals 180. So if one of these three is missing, we can solve for it simply because we know that all three have to equal 180 when added. A triangle is formed by three line segments that intersect only at their endpoints. A point where the segments intersect is a vertex. The angle formed by the segment that lies inside the triangles is an interior angle. So these are the interior angles. We have acute, acute, and what seems to be almost a 90-degree, I would think. Okay. And here's our first example. We have this beautiful flag here of Antigua and Bermuda. So find the value of x in the Antigua and Bermuda flag. And they want us to find this right here, this x, right? And look, we've already been given a clue that this is a right angle, which equals 90. So simply put, we could say that x, right, plus 55 plus 90 equals 180, right? So we solve for x. Let's collect like terms. We add these two up and we get 135, right? 145, I'm sorry. 145 equals 180, and it's still plus x, right? And then we have to isolate the x and invert the operation. So we have our 180 minus 145, and we solve right there, and x equals 35. Okay, so that's the way we would do it in class. Over here, they're using the property of subtraction of equality to subtract the 145 from both sides in order to isolate the x, which is what we did. We just inverted. We didn't use the property. We simply inverted the operation, and we have x equals 35. Okay, so if you think you got it, solve for triangle x, y, z. If measure of angle x is 72 and measure of angle y is 74, what is the measure of angle z? Go ahead and pause the video and try it now. Pause. I hope you paused the video. So this is what you should have. X plus y plus z equals 180. Replace your variables. We have x equals 72 plus y equals 74 plus z equals 180. Okay? Now let's collect our like terms. And here we have 146. 72 plus 74 is 146. Right? Plus z equals 180. Let's isolate the variable. So I'm going to bring this 146 over to the other side to subtract it. So it's gone from here. And now I just have z equals, I believe it's 34. Yeah, 34. There we go. Example 2. The measures of the angles of triangle ABC are in the ratio 1, 4, 5. What are the measures of the triangle? So when one angle equals 4, or when one angle is 4, the other angle is, I'll repeat that. When one angle is 1, the other angle equals 4, and the other angle is 5. So this is how they're going to proportionally increase. So this angle will always be 4 times larger than this angle, and this angle will only be, proportionally speaking, a quarter larger than 4, right? Because a quarter of 4 is 1. So this is larger by a quarter, by 25%. So let's see. Let x represent the same measure of angle A. So then 4x and 5x represents angle B and C. So this is 1x, right? We don't know what our measurements are, but we do know that they're always increasing by this amount, right? So as I mentioned, this would always be 4 times larger, and this one would always be 5 times larger than the first one. Okay? So we're going to go ahead. We would just solve this algebraically, as we've done before. Let's collect our like terms. And how many x's do we have here? We have 4x's, 5x's, and another x. Together is all 10x. And then we divide the 10, both sides by 10, so that we can get rid of the 10. So we would use division property of equality. And we get x equals 18. So now that we know that x is 18, we know that our first angle is 18, and then this one is 4 times 18, which is 72, and this one's 5 times 18, which is 90. And the sum of all three angles, 90 plus 72 plus 18, gives us our 180. Okay, if you understood that last example, please pause the video now and try this question on your own. Pause now. The measures of angles of triangle LMN are in the ratio 2 to 4 to 6. Okay, this is how they're going to increase. What are the measures of the angles? Well, we know that we have our 2x here, our 4x here, and our 6x here. We don't know what our angles are, so we're representing them by x, but we do know that this one is 2 times the size of it, this one's 4 times, and this is 6 times. Let's collect our terms, and when we collect them, we get 10x here plus 2 is 11x, right? 11x. Oh, I'm sorry, I did that wrong. It's 12x. Sorry. Good thing I have an eraser. So yes, 2 plus 4 is 6 plus 6 is 12. So I have my 12x, all right, equals 180. Now I'm going to use division property of equality to divide out the 12 and divide out the 12 in the 80, so I can isolate my x. I'll continue doing that up here. So now I'm just left with my x equals 180 divided by 12 is 15. Okay, I'll put my 15 here. So if that's the case, then when I replace it, I get 2 times 15 here is 30. So my first angle is 30. 4 times 15 is 60. And 6 times 15 is 90. So it's 90 plus 60, that's 150, plus 30 is 180. So that's true. Okay? So that's what we want to do. We want to say that this ratio right there, okay, this ratio right there goes 30, okay, 60, and 90. And there we have it. Those are our three angles. Okay, now we have moved on to our second key concept of this lesson. And here we go. Now we're talking about exterior angles of a triangle. The measures of an exterior angle of a triangle is equal to the sum of the measure of its two remote interior angles. So here we go. The measure of the exterior, okay? So we have measure of angle A plus measure of angle B equals measure of angle 1. So that's what we're saying. We're saying that this measurement here and this measurement here, when we measure these, we're going to get this one. So the measure of an exterior angle of a triangle is equal to the sum of the measure of its two remote interior angles. So whatever we have in here, two remote interior, whatever measurement that is, and whatever measurement that is, when we add them up, it's going to equal this measurement here. Does that make sense? In addition to its three interior angles, a triangle can have an exterior angle formed by one side of the triangle and the extension of the adjacent side. So one side and the extension of the adjacent side, the side next to it, right? Each exterior angle of the triangle has two remote interior angles that are not adjacent to the exterior angle. So if we have an exterior angle out here, we have two remote. Remote means on their own, off on their own, that are not adjacent to this. There's no angle next to this one, but these guys are next to one another. Here's another example. We have exterior and interior. Okay, so exterior we have angle 4. So our remote adjacent angles would be 3 and 2, right? So angle 4 is an exterior angle of the triangle. Its two remote interior angles are angle 2 and angle 3, as you can see, right? This one's on its own. So the measure of angle 4, the exterior, is equal to the sum of the measure of angle 2 plus the interior angle of measure 3. These are interior, and this is exterior. Example 3. Suppose the measure of angle 4 equals 135. So here's angle 4, and it equals 135. Okay, so we have that so far. Over here is 135. And we know that this equals the two interior angles, this angle and this angle. And we already know what this angle is, right? It's a right angle, which equals 90. So we have, essentially, if we represent 2 with x, we have x plus 90 equals 135, right? So because we have that, we can say angle 4 is an exterior angle. Its two remote interior angles are angle 2 and angle LKM. Angle LKM. You see that? That's what they call it. The letter in the middle is the angle. We have LKM. So this is the angle we're talking about right there. Got it? So measure 2 plus measure of angle LKM equals measure of angle 4. We already know that. So we have x plus 90 equals 135, as I mentioned earlier. We do subtraction property of equality, or we can just simply bring over the 90 and subtract it, and we get x equals 45. So the measure of angle 2 is 45. There we go. Which I think you guys can add a little bit more to this. If you know that this is 45, right, and you keep going, you can solve for angle 5, because you know that from here to here also has to equal 180, because they are supplementary angles. Supplementary angles equals 180. So 45 plus x equals 180. So this would be 135. This would be 135. And if this is 135, these are exterior alternate angles, 4 and 5. Okay. And because of that, we've solved for angle 1. We know that this is 135, so this angle 1 must also be 45. So we have 45 plus 90 equals 180 in the interior angles. And there, we just solved for all the angles. Okay, if that made sense to you, please go ahead and try this question on your own. Let's look at it together first. Refer to the figure at the right. Suppose that measure of angle 5 equals 147. Here's angle 5 equals 147. Find the measure of angle 1. So they're using the same image from the last one, but they've given us a different measurement, because we already solved this. We knew it was 135 because this was 45. But now they're telling us that it's 147. So we know that that's 147. Okay, if you know how to go from here, please pause the video, try it on your own so that you challenge yourself, and then check my answer. Pause now. Okay, I hope you paused the video. There's a few ways to solve this. You see that if this is 147, right, we know that in addition to 2, if we say that measure of angle 5 is 147, let me erase that and just write 147. I'm just going to write 147 plus measure of angle 2, right? That equals all 180. That equals all 180, right? So we know that now this is 180. If this is all 180, we can solve for 2, and I already know that I have my 90 degree here, right? So I can go isolate by bringing this over, or do the subtraction property of equality, and I'm just going to subtract the 147 from this side, right? And that's going to give me 33. So angle of measure 2 equals 33, right? So now I have 33 plus 90 plus measure of angle 1 equal 180, right? So if I have that, I can go ahead now and solve for measure of angle 1. So I will go ahead and do that. I will collect my like terms first. I have 123 right here. 123 plus measure of angle 1 equals 180. Now I'm going to isolate measure of angle 1 by bringing the 123 over to this side. Okay, and when I do that, I get measure of angle 1 equals 57. You see? So we just solved it. So here's your guided practice. Please go ahead, take a look through it. Make sure you feel comfortable with it. Go back to the examples in the video if you don't understand. And if you still don't understand after you've done that, bring your questions to class. See you in class, everyone.